A ring is hung on a nail. It can oscillate without slipping or sliding in its plane with a time period t1, back and forth in a direction perpendicular to its plane with the period t2. The ratio t1 by t2 will be, so we know that time period of an oscillating object is given by t is equal to 2 pi root of moment of inertia over mass of the object into g into length of the pivot till the center of mass of the object. So when the ring is oscillating in its plane, the moment of inertia will be mr square plus mr square, because the ring is moving in this direction and this direction. So we'll add both. We'll plug it into the formula for finding T1, and we get T1 as T1 is equal to 2 pi root of 2r by g. Now, when the ring oscillates perpendicular to its plane, the moment of inertia is calculated along the tangent. So it is given as 3 mr square by 2. After plugging it into the formula for time period, we get 2 pi root of 3r by 2g. Now we're down to the last step. We simply divide t1 by t2. We get root 4 by 3. Upon further simplification, 2 by root 3. So the correct answer would be option number 3, 2 by root 3.